All right, guys, today we're going to start with simplifying radicals. Something we've already learned before. We're going to start with a little refresher, and then we're going to talk about doing it with variables as well. So to simplify a radical means to reduce its form, not getting a decimal for it. Simplify the expression. We do not want decimals, okay? So if you remember, we just make the factor tree. What multiplies to give me 12? So let's just do 6 and 2. 6 is done because nothing multiplies to give me 2 besides 2 and 1. 6, I get 3 and 2. Okay. And 2 and 3 are done as well because nothing multiplies to give me those numbers except 2 and 3. So you can either see that you have a pair here, okay, and that's the number that we're pulling outside, and we have one loner here. Okay, you can also see, you can write them all out if you need to. Okay, I have a group of 2 that I'm pulling on the outside here. Okay, needs a friend to come out and play, so I bring a 2 out to represent that pair, and then just leave what I have left inside. So 2 radical 3. All right, example 4. Breaking it down, what multiplies to give me 54? If it's an even number, you can always divide it by 2. If something you just know, like I know that 9 times 6 will multiply to give me 54. 3 times 3 will multiply to give me 9. Those numbers are dead because nothing multiplies to give me it besides that number and 1. And then 3 times 2 here. Okay, you can see that I have a pair of 3s here. I know those are coming on the outside, and then I have 3 times 2 that would be left on the inside, and when you have 2 numbers left on the inside, you just multiply them together, so 3 times 2 would give you 6. 3 square root of 6. Example 3, okay, gonna break it down. If you divided this by 2, you would get 36. 2 is a dead number because of 2 times 1. If you understand that 36 is a perfect square, you can just stop right there and square root 36. The square root of 36 is 6. Okay, and I have a 2 left to give me square root of 2. If you don't know the perfect squares, it is 1, 9, 16, 25, 49, or 36, sorry. Skipped one. 36, 49, 64, 81, 100, 121, 144. So that takes me all the way up to 12. So 1 times 1 gives me 1. 3 times 3 gives me 9. Oh, 2 times 2, 4. It's also a perfect square. 3 times 3 gives me 9. 4 times 4 gives me 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. So that's how we pull out the pair. Once you square root a number, so like I square rooted 36 in example 3, there's no longer a square root around my 6 because this breaks down into 6 and 6, which gives me that pair that I'm pulling out on the outside. Okay. Now with example 4, it is the cubed root, which means I need to find 3 numbers. Okay. I need to find a group of 3 now. So let's break this down. We can look just above because we did 54 up there. If I did 9 and 6, 3 and 2, those are done. And I did 3 and 3. Okay. So now since I'm looking for a group of 3, I would use this group of 3 right here. Okay. And that's the number I'm pulling out. So it would be 3 cubed root of the number that I have left, which is 2. Okay. If you wrote this out, it would look like this: 2, 3, 3, 3. There's my group of 3. So you're always trying to match this number. Remember, if there's no number there, it is just a square root. So just 2. Okay. For example 5, we're going to break this one down as well. Let's do 10,000. So I know it's 100 times 100. Okay. 100s break down into 2 and 50. 2s are dead. 50s break down into 2 and 25. 2s are done. 2 and 25. 25 breaks down into 5 and 5. Okay, so I'm going to go ahead and write this out. Remember, I'm looking for groups of 3 because it's cube root. I have 4 2s, and I have 4 5s. Okay, I have a group of 3 right here, and then I have another group of 3 here. So that means I'm pulling out a 2, and I'm pulling out a 5. So when I pull out 2 numbers, I need to multiply those on the outside too. So 2 times 5 will give me 10. Cube root of 2 times 5 on the inside, because that's what I have left. So it would be 10 cube root of 10 for my answer. There's your answer to that one. Highlight these answers. Okay, so now with example 6, it is the 4th root of 160. So now I'm looking for groups of 4, okay? 160, 16 times 10. 10 gives me 2 and 5. Those are both done. 16 gives me 4 and 4, which then gives me 2 and 2 on both of them. So you can see here that I have actually a group of 4 right here. So 2 is the number I'm pulling out with the 4th root of the numbers I have left, which are 2 and 5. 2 times 5 will give me 10 on the inside, okay? Remember to keep that little number there, whatever it is. So 2 to the 4th radical of 10, okay? Any questions, let me know on simplifying radicals. Now we're going to talk about variables, okay? So same kind of thing. We're still looking for groups of whatever the radical is. If you look at example 7, it is a square root. So I'm looking for groups of 2. And if you think about how many groups of 2 do you have in x to the 4th? Well, you have 2 groups of 2. So if I think about it, I have 4 x's because that's what x to the 4th means. I'm looking for a group of 2, and I have 2 of them. So I'm going to pull that outside. So I'm pulling out 2 x's. If I multiplied 2 x's together, I would get x squared. And that would be my answer because I have nothing left on the inside here. Looking at example 8. So now I have 7 x's. 1, 2, 3, 4, 5, 6, 7. So looking for groups of 2 because it's a square root. There's 1, 2, 3. So that would be x to the 3rd. And I have 1x left over, so I'm leaving that on the inside. And that would be your answer. For example 9, it's a cube root here, okay? So I have x to the 6th. If I have 6 x's, okay, I'm looking for groups of 3. I have a group of 3 here and a group of 3 here. So my answer would be x squared. Example 10, now I have 8 x's. Groups of 3, so there's 1 there, and I have 1 here. So I have 2 groups of 3, x squared, and then I have 2 left over. So if I have 2 left over, I'm putting x squared on the inside as well because there's still 2 x's. Pulled out 2 groups, and then I have 2 left. Don't forget that 3 there to let me know that it is a cube root and not a square root. All right, example 11. Now I have 2 variables, and I need to do the same thing for both variables. So let's look at the x's first. I have 5 of them. Okay, I'm looking for groups of 4, okay, because it is the 4th root. I have 1 group of 4 with an x left over. And then I have 6 y's. And I'm looking for a group of 4. I have 1 of them, and I have 2 y's left over. So I would write that as y squared. And that would be my final answer. Okay. Now with example 12, I have numbers and letters, okay? And this is going to be the case most of the time for our problems. You need to simplify both of them. So I would simplify your number and then make sure you do your variables, okay? If we made a factor tree for 27, we know that 9 times 3 gives us 27, and then 3 times 3 gives us 9. You see there that you have a group of 3, which tells me that 27 is a perfect cube root, because it is a cube root. That's what I'm looking for. So I would pull out a 3. And then if we look at the variables, I have 4 x's. I'm looking for a group of 3. I have 1 that I'm pulling out with a cube root with 1 left over right here. That needs to go on the inside. And that would be your final answer right there. Okay. If you guys have any questions, let me know. If not, have a great day. Make sure you get your assignment done.